In the highly competitive field of programming competitions, OpenAI's latest research has attracted widespread attention. Their large reasoning models showed remarkable performance at the International Olympiad in Informatics, IOI, and on the Codeforces platform, the latest O3 model achieved 2,724 points on Codeforces, surpassing 99.8% of contestants, and achieved gold medal level performance in IOI 2024 tests. This research outcome from OpenAI demonstrates the latest advances in AI's ability to solve complex programming problems. This video will provide a detailed explanation of this research by analyzing the performance of three different versions of the model. O1, O1, IOI, and O3, we can clearly see the development trajectory of AI programming capabilities. First, let's look at the performance of OpenAI's O1 model. This is a large language model trained through reinforcement learning, which can solve complex problems through step-by-step reasoning like humans. On the Codeforces platform, the O1 model achieved a rating of 1673 points, surpassing 89% of human competitors. This score shows significant improvement compared to the early version O1, Preview's 1258 points, 62%, and GPT 40808 points, 11%. Next is the O1 IOI model specially developed for the 2024 International Olympiad in Informatics. The research team conducted targeted reinforcement learning training based on O1 and designed special test time strategies. These improvements helped O1 IOI achieve a score of 2,214 points on Codeforces, surpassing 98% of the participants. In the actual 2024 International Olympiad in Informatics IOI competition, O1 IOI scored 213 points, ranking approximately at the 49th percentile among all participants. Here, 49th percentile means that about 49% of participants scored lower than O1 IOI, while 51% scored higher than it, indicating that the model performed at a medium level under this strict scoring system. It should be noted that competitions like IOI typically impose strict limits on the number of code submissions from participants. For example, a competition may only allow each participant to make 50 submissions. This submission limit is intended to force contestants to submit their best solutions within limited attempts, thereby preventing high scores from being achieved through excessive trial and error strategies. When the competition relaxed its submission restrictions, contestants or models could have more opportunities to try, thereby improving the performance of related algorithms and code. Under these relaxed conditions, O1 IOI score improved to 362.14 points. This score exactly met the gold medal standard set by the competition. The gold medal standard typically represents the top-level performance in that competition and is an important recognition of the participants' overall capabilities. It is also one of the highest honors in the competition. The most notable is the performance of the O3 model. This model did not use any special testing strategies, relying solely on more reinforcement learning training, and achieve a high score of 2,724 on Codeforces, surpassing 99.8% of participants. In the IOI 2024 test, the O3 model achieved 395.64 points, even under the standard 50 submission limit, far exceeding the gold medal threshold. These achievements reflect an important trend. General reinforcement learning training may be more effective than specially designed strategies. The O3 model demonstrates that it can develop testing strategies independently, such as verifying the correctness of optimization algorithms by writing brute force solutions. This autonomous learning ability may indicate a new direction for AI in solving complex problems. The research team also tested these models on actual software engineering tasks done on the HackerRank Astra dataset. The O1 model achieved a first pass rate, pass at 1, of 63.92%, and an average score of 75.80%. This dataset contains various problems from real programming interviews, covering multiple aspects including data structures, algorithms, system design, etc., which can well reflect the model's performance in practical programming scenarios. In the SWE Bench verified test, the O3 model showed a 22.8% performance improvement over O1. SWE Bench is an open-source software engineering benchmark set. It collects bug fixes and feature implementation tasks from real open-source projects. This test not only requires models to understand code logic, but also needs to consider the overall project architecture, code style, and best practices. O3, the advantages demonstrated by the model in these tasks that are closer to actual development indicate that these models' capabilities are not limited to competitive programming, but also have potential applications in real development scenarios. However, we also need to be aware of the limitations of this study. Although these models perform well on specific tasks, they still require significant computational resources and training data. Moreover, whether the models truly understand the essence of the problems or have merely learned problem-solving patterns, this question still requires further investigation. Overall, this study demonstrates AI's progress in complex reasoning tasks. Through continuously improved reinforcement learning methods, AI systems' capabilities in programming are gradually approaching or even surpassing human expert levels. This may herald a new transformation in the field of software development, but it also reminds us to carefully evaluate the practical significance and potential impact of these advances. Let's look forward to more research results in the future to help us better understand the capability boundaries of AI systems and how to better apply these technologies to practical problems.